Hello, welcome back. Today we're going to be looking at some numeric types. So we went into basically what types are last time, looked a little bit at the differences between classes and structs, and now there's some more stuff to talk about types. So the book has a little table on numeric types, and there's not too much different than you would expect in a regular programming language. The only thing that I noticed is that there's actually a decimal type. So it's basically a double, but double the amount of space that you're given. So a decimal is 128 bits, where a double is only 64 bits in size. So that's a little bit interesting. A float is also half a double, so that's only 32 bits. So anyways, that's pretty cool. I did not know that that was a thing. A little bit useful if you want to have a very long decimal number. So let's start by looking at some of these guys. So you are able to create numeric types in two different ways. You can declare an integer like this, or some type, and you can also do something like this. If you do 0x24, you're actually doing this in hexadecimal notation. And I think it's been a long time. This is 16, so like 32. I think this is 36. Don't quote me on that, but this is the hexadecimal representation of a number. So it would be the same thing if this were to be 36. I could write y equals 36, and it would be the same thing. You can also use scientific notation too, which is pretty cool. If you type 1e and then 06, this is 10 raised to the 6th, so which is a million, which is why that is called a million. By default, if a type has a decimal point after it, C# is going to assume that you are talking about a double as a variable name. But this isn't necessarily the case because we were talking about that decimal data type, and there's also a float too. So you have to specify what type you want if it's a little bit vague. So where this comes into play is if you want to create a float, then you can do 24.5 and then you have f after it. And then this f is signifying that you actually have a float instead of a double. Because otherwise, no f, it would assume that this is double. And I actually want to do this example as if I do decimal and then d and set this equal to 243.24, right? We won't be able to compile because let's see, the error says that this represents a double precision floating point number, literal of type double. So what this means is that C# is assuming that since this has decimal point after it, it's a double. So we have to actually specify that what we want is a decimal, and you have to do that with this m character after the number. So now it's fine. Program will compile, and it just shows the necessity of specifying the type. The nice thing about Visual Studio and just most IDEs now is you'll get the red squigglies before you compile, so that way you don't have to worry about those errors and you'll know that you'll probably have to specify that type if you're having problems. One thing that I didn't hit on as much as I wanted to last time was this idea of type conversions and when you need to explicitly convert something rather than just implicitly converting something. So I'm going to delete all of these besides the x and show this. So I can convert a new double. I can convert this x into a double easily. This is called implicit conversion. Implicit type conversion. And basically what's happening here is it's turning this x, which is a 14, it's turning this into a 14.0. So you're just putting on that decimal point. The problem would be if we create another int and we want to assign it this double. We get red squigglies here, and the error says they cannot implicitly convert type double to an int. An explicit conversion exists. So what that is saying is that we cannot use this implicit way of converting, and we have to use explicit conversion. And the reason we have to do this is because we're going from this 14.0 and we want to take it down to 14. So what's happening here is we're actually losing data. We're losing everything after this decimal point. When you're converting from one type to another and you're going to lose data, that's when you have to explicitly convert and tell C#, okay, I actually know that I'm going to lose data here. That's okay. I still want to convert this type. So I have to say that I want this to cast to an int, and this is explicit conversion. So it's converting this 14.0 into 14, and it all works. All right. Let's get rid of these guys. C#, just like C++ and quite a few other languages, has incrementation on it. So basically, or I should say inline incrementation. And basically, that just means that we can do x++. And basically what this is doing is it's saying, it's just a shorter way of writing this. And doing this does the same exact thing, and it's the same way as writing this. But there's a difference between these two, obviously. And let's show the difference between those two here. So I'm going to comment out these lines so that way we're not incrementing x and it doesn't mess up what we're trying to do here. And I'm going to start up the program. Again, really quickly, got to add in a console.read key so that way we can see our results. So I'm going to start this up. And so we started with 14. And so when we use console write line, it prints out 14, but we are incrementing x. And then the next time it prints out 16. So what's going on here is that this x right here is 14. And when you add the two pluses on the right side, what console write line is going to do, it's going to pull this x value out from the start. So whatever x is before this line is called is the value that it's going to use. So obviously that was 14, that's why I printed out 14. And then after console.writeLine has shown the x value, then it's going to increment it by 1, so that it goes up to 15. So then when we come down to this line, x equals 15 here, before we even get into the statement. So now we have x here, but it printed out 16. So when you actually include the pluses on the left side of x, that means that console.writeLine is going to take x plus 1 before it prints it out. So basically, if you have the pluses on the right side, it's going to use the value before and then increment it. And then if you have it on the left side, then it's going to use the value plus 1 as whatever it's going to print out or use. So that's just an important distinction. It's actually a pretty nifty thing to have and just sort of a nice thing.